right, we've got one last trend. All right, the last trend we've talked about already. It's the last one that you guys looked at on the activity, and that is electronegativity. All right, electronegativity is the ability to gain an electron. So similar to ionization energy, it takes to lose an electron. Now we're looking at an electronegativity, which is the ability to gain electrons in order to help, again, satisfy that octet rule. So for this one, the closer you get to fluorine, the higher the electronegativity. So our diagram, fluorine would be our highest. And again, as we go from left to right, we would increase. And as we go from the bottom to the top, we would increase. All right, and we have a disclaimer, if you will, about our noble gas family. So obviously, if we're increasing as we go from left to right, but fluorine is the highest, that means what happens with the noble gases that are on the other side of fluorine? Well, the noble gases actually have the lowest electronegativity. Matter of fact, some of them don't even have an electronegativity number. So when you guys were creating the diagram, the group that had electronegativity, there were several of the noble gases that were just zeros, or it had a line, meaning that it didn't have one that even existed, right? So the noble gas family has the lowest, but then everything else from family 1 to 17 increases as we move towards fluorine. So why? Why does it increase, and why does the noble gases have the lowest? So let's talk about the noble gases first. All right, why would the noble gases have the lowest electronegativity? How many valence electrons does the noble gases have? 8. What number did I tell you was what everybody wanted? 8. So if they already have 8, then do they really need any more electrons? No. So that's why they don't have a very high electronegativity, because electronegativity is the ability to gain electrons. They don't want any electrons, so they don't need any electronegativity. So our noble gases don't need any more electrons. That's why they are the lowest. All right, let's talk about the other part of the trend. Why do we increase in electronegativity as we go across the periodic table? it's almost the same as ionization energy was. The more valence electrons an element has, the more they get closer to that 8 number, the more they're like, yeah, give me some more, give me some more. So chlorine and fluorine and bromine and iodine, they have 7 valence electrons. So they have high electronegativity because they only need 1 more in order to be complete or stable. All right? So for the rest of these guys, the more valence electrons an element has, the easier it is to gain electrons, which gives them a high ability for electronegativity. All right, so let's look at a couple of examples with this one. Let's put these in increasing order. Let's say we have C, O, N, B, E, F, and N, E. All right, we're going to put these in increasing order for electronegativity. So the first thing that I would do is always look to see if I have a noble gas. Because if I have a noble gas, it's going to be the lowest automatically. So do I have a noble gas up here? Yes. Neon is a noble gas. So I'm going to write it first. Now I'm looking for the one that's furthest left on the table, and then I'm going to work my way back. So which one would come next? BE. Next would be C. Then N, followed by O, and finally F. All right, everybody understand how to put these in order?